The purpose of this presentation is to propose a GIS system for the City of Wilkes-Barre, Pennsylvania, capable of displaying critical asset data for both internal and external stakeholders. The City Public Works Department has an inventory of GIS data based on traffic and stormwater assets, including traffic signs, supports, hydrants, storm drains, valves, and manholes. The project aims to operationalize these foundational city assets by improving the request for maintenance process and accurately tracking the life cycle of an asset. The City of Wilkes-Barre's Public Works Department is tasked with multiple functions. Two of the most important include placement and maintenance of various road signs and maintenance and repair of sewers and storm drains. Both functions involve asset management, specifically traffic signs, manholes, storm drains, valves, and hydrants. The city has these assets in GIS format, but does not have a current GIS system to operationalize the data. In addition, the city needs to improve its maintenance request platform for public safety and for tracking the life cycle of assets that collectively equate to well over $1 million in value. There are several users within the city and outside the city that will be interested in this data. Public Works traffic staff will be interested in the traffic signs and supports data and attribution. They will need to understand where they are located and the attribution to assist in replacement and maintenance. They will primarily use the GIS data to understand spatial patterns and the life cycle of a sign. Stormwater staff will be interested in the hydrants, manholes, storm drains, and valves. Like the traffic staff, they will need to understand location. They will also need to understand the spatial relationships, as many of these assets are interconnected through underground infrastructure. While they manage different assets, both departments will share three personas, which include GIS analyst, maintenance worker, and decision maker. Members of the public will be interested in the asset data, specifically signs, to report any damage. Signs are subject to graffiti, traffic accidents, and weather. Maintaining regulatory signs is a matter of public safety, so giving the public a mechanism to report issues is an important aspect of this project. After considering a few options for this GIS system, Esri's ArcGIS environment is the best choice due to its convenience and low impact on IT resources. Their software as a service platform, ArcGIS Online, provides an easy way to host, share, and create web applications. ArcGIS Pro will be used by the city GIS analyst to do any advanced spatial analysis. The cost of this platform is less than an on-premise solution, and the maintenance and technical requirements are less burdensome than a fully open-source platform. The first proposed application is for internal stakeholders to search, filter, and edit data. The application is hosted on Esri's ArcGIS Online platform and therefore accessed through an internet browser. Each City Public Works employee will have access to Esri's platform and the subsequent applications once they are logged in. The project calls for two separate applications, one for traffic and one for stormwater. The designs will be identical, just with different assets. This will ensure upkeep for both applications is easier on the GIS analyst and will also provide flexibility if there is a business need for one group to add or remove the features the other one wants to keep. The user steps for an application like this will start with going to the URL and logging into Esri. The internal stakeholder will then see the application with the map set to the default view of the entire city. There are four functional widgets at the bottom of the page. The first from the left is a legend that shows the symbology of the assets. Users will open this to understand what they are viewing on the map. Depending on the user, they may want to change the base map. Topographic is on by default, but aerial, streets, and OpenStreetMap are all useful and comfortable for different users. Since there is a high density of signs, users may want to filter the display to only show specific types of signs or those in specific conditions. Users have the ability to search for a specific sign or address by using the search bar in the top right-hand corner. Upon searching, the map is centered and zoomed to the location. The user can then adjust their view by clicking and dragging with the mouse or adjusting their zoom with the zoom buttons in the top left-hand corner. Once the user has navigated to the desired asset, they can click on it in the map. This will show a pop-up with its tabular information. Users can edit this information by clicking the Edit widget. Here are examples of the widgets mentioned, including filtering and editing. Filtering includes a drop-down and activate button, while editing includes multiple drop-downs to influence the tabular data. The external application will look very similar, but with fewer functionalities for a simpler user interface. However, maintenance requests will be handled through a form like this, including reason for the work order. The system requirements are based on the Esri suggestions available on their website. Since the majority of the system is provided in a software as a service model, there are very few concerns other than having an internet connection and access to a web browser to view the applications. This framework will support the three-tiered system shown here, including data analysis, data hosting, and ultimately consumption. As mentioned previously, the data at the center of this project includes traffic signs and supports, hydrants, valves, drainage basins, and manholes. Most of the data included is vector proprietary information hosted as an Esri feature service, but base maps provided by Esri will also be part of these applications. There will be three primary evaluation methods used to understand system requirements, assess the success, and implement applications that are part of the proposed GIS system. The first method will be surveys sent out to internal stakeholders to understand the requirements of the applications and data. The questions in the survey will be a series of yes/no questions designed to understand the underlying functions and applications that this needs to include. The second evaluation method is focus groups. Focus groups with representatives from internal stakeholders will be used to evaluate the functionality of the initial web application development. They will be tasked with testing the functionality and providing feedback for the internal web applications. The final evaluation method will utilize tabletop exercises to test the functionality of the public-facing application. Since the proposed application has a feedback mechanism, it's important to test that functionality before releasing it to such a wide audience. The costs of this GIS system will be roughly $10,000 per year to accurately track, log, and engage with the public. While there is a high cost associated with this project, it provides the most convenient and least onerous solution for staff at the city. The GIS system allows for advanced spatial analysis, consumable web applications, and a mechanism to easily share and receive feedback from the public. The infrastructure is provided as a software as a service model, putting the responsibility on the vendor, Esri, to manage and maintain IT infrastructure like servers and applications. The work schedule for this project will take place over a 5-week span, starting with stakeholder engagement and ending with web application deployment. It includes 3 phases: design in green, implementation in purple, and deployment in orange. The work will not be conducted on weekends and will focus heavily on active engagement throughout the process. The UML design for the City of Wilkes-Barre GIS system is based upon the relationship of 3 types of users and the GIS analyst that is providing the data in the Software as a Service hosting environment ArcGIS Online. The users of the applications, or actors, include internal public works stakeholders, maintenance crews, and members of the public. Internal stakeholders will interact with an internal web application by logging in, searching for an asset, and investigating its status by clicking on that asset. Maintenance crews will have an additional ability to edit the attribution of an asset, indicating that they have completed work. That data is then saved to the ArcGIS Online cloud. Members of the public will interact with a separate, public-facing application that allows them to submit maintenance requests. The data inputs from both maintenance crews and the public have required fields that need to be filled out to successfully save changes or requests. Like maintenance crews, any submitted information is automatically saved to the ArcGIS Online cloud. On the right side of the diagram is the GIS analyst. The initial data upload of the asset features will be handled by this GIS analyst, who serves as a secondary actor. The GIS analyst makes the asset data available in the web applications and can export those features for additional use in ArcGIS Pro or in spreadsheet form for other city employees to consume. Thank you for listening to this GIS system proposal. I am confident that the design will lead to an efficient and cost-effective way to track assets and engage with the public in a more proactive way. The results of this project should directly impact the city's ability to contribute to public safety and to more appropriately track the cost of individual assets.